Hello there, my name is Luabikoye and I'll be the one taking you on the AWS cloud computing training. Um, I'm sure you must have heard a lot about AWS, how AWS has been one of the frontiers in terms of cloud infrastructure, cloud computing, automation, and so many things. Now, one of the things we would achieve with this training is to be able to take you through the journey of AWS in the most simple and straightforward way. A lot of people are always intimidated when they listen to other trainers or when they hear things around cloud computing and infrastructural activities. So, my approach to learning is pretty straightforward and very easy. So, let's get at it. First of all, what is AWS? AWS is the world's most comprehensive and widely adopted cloud computing platform provided by Amazon. It offers a vast range of on-demand services like computing, power, storage, databases, networking, machine learning, and more. They make all this accessible on the internet um, at a pay-as-you-go basis. Now, why AWS? AWS is cost-effective. You pay only for what you use, no upfront hardware costs. It's scalable, easy to scale resources up or down to meet your demand. It's reliable, it's built on the global infrastructure, ensuring high availability. It offers advanced security features and compliance certifications. Continuously adds new services and features. You see, the last bullet for me here is very important. They continuously improve on their services. They try to make sure that they are ahead of the game. Now, these are critical things that you must consider when considering going into the cloud as a cloud engineer or as a solutions architect or just a practitioner. Now, I won't be diving into comparison, and the reason is because people have their preference. Some people started using other platforms, but one of the most popular one is Google Cloud. We know Azure, and among the two of them, these are the major difference. AWS started in 2006. They are still the largest in cloud computing, and they are more mature with wider range of services. The thing about Google Cloud is they're also rapidly growing and they have strong focus on AI. We also have other platforms like Azure, Microsoft Azure. However, I want to stick to what we'll be learning here, which is AWS. Now, the core services, the core AWS services are things around the compute. So you see Elastic Cloud Compute, which is EC2. And the abbreviations are actually out of what the service full names are. So E, then you have two C's. That's where the EC2 comes from. Elastic Compute Cloud. These are virtual servers running your applications. Lambda, serverless computing. They run code without managing servers. You now have ECS, EKS. These are how you manage your containers, for Docker and Kubernetes. We'll be looking deep into these services. Another services that we have that's very useful and popular is the storage. AWS have very strong storage infrastructure. One of them is the S3. That's the 3S. Simple storage service. It's a scalable object storage for files and backups. When we get to the hands-on, we'll be able to get clearer understanding around this. But when it comes to you want to save your files, you want to keep your files somewhere on the internet, and in the cloud rather, you use S3. Their ability to manage huge data, migrating data to their infrastructure, and having a solution for just storage. Now, EBS is Elastic Block Store. These are persistent storage for your EC2 instances. You come to understand that these are storage that comes with your instances. Instances are like your servers in however, these are how your servers are defined in AWS. So we have Glacier. These are local storage for archival and long-term backups. You get to understand how all this works. So another core service AWS offers databases. So you have RDS. These are relational databases like Microsoft SQL, PostgreSQL, Oracle. They have DynamoDB, which are fully managed NoSQL databases. They have Redshift, data warehousing for big data analysis. Now we move to networking and content delivery. Networking is how your website are delivered, how your domain route to your servers, how content are delivered faster using CloudFront. Pretty much is just to see how your services are going to be connected to themselves, how you connect your database to your servers, how you connect your domain to your load balancers and thereabouts. So you get to understand more of this item. So we also look at security and identity, how you manage user permission, how you encrypt your data and manage them with keys. And machine learning and AI, these are also some of the core services that AWS offers. So SageMaker, recognition rather, then Lex, these are other. So there are the common use cases for AWS are hosting website and web application, data backup and disaster recovery, machine learning and data analysis, internet of things solutions, game development and mobile apps, and so many more. A typical example of scenarios are launching an e-commerce website. Use EC2 for hosting the website. You can store images or your files or very important documents on S3 for scalability. Use the RDS for handling transactions. So while your service is running on the EC2, files and documents and important uploaded objects are saved in the S3. Your data itself in terms of database are stored in the RDS, and you can now distribute content globally via CloudFront. So CloudFront is something that we'll look at pretty much, and what CloudFront is used for is to orchestrate how the distribution of your of your content are. So I could be in the US, I'm trying to access your platform. How can my services deliver content to me pretty fast and easy? And one of the powers AWS has, which is something we'll look at, is how their infrastructure are distributed. So AWS is AWS has a very interesting infrastructure. So I can just Google AWS infrastructure. I'll use this to also explain how AWS infrastructure looks like. So from their website you can have a clear view of how their infrastructure is. Now AWS has 36 launched regions as at today. We're in April 2025. They have 114 availability zones and they have 700 plus CloudFront POPs. Now what does this mean? If you look at the map closely, these are where AWS exists. All these regions, these are all their regions. So it means that AWS has physical data centers in this region. So they have a data center in Canada West, they have a data center in North California, they have a data center in South Africa, they have a data center in Sao Paulo, they have a data center in Nixia, they have a data center in Hong Kong. I think the ones the rest are the ones that they've started working on. So these are where all their data centers are. Now when you say they are in a region, it means they have physical presence here. Now if you look at the Canada Central, somewhere below you can see availability zone shows 3. So in Canada Central, what this means is AWS has 3 different physical data centers at different locations. So these are called availability zone. What this means is once you deploy a solution on AWS and you have them running in what we call a multi-AZ, that's multiple availability zone, it means that if something happens to your data, or let's say there's a disaster in one of the data centers, it won't affect your services. Your services will not be down because one of the availability zone will have a replica of your solution and it just picks up the traffic from there. So it just means that I have my solution running in Canada and I live in Africa. If majority of my audience or my target audience are in Africa, it would only be nice for me to make sure that I deploy my solution in the Cape Town data center because it's the closest and the only region in Africa. This is just to manage latency, so that you can have low latencies. The response time from your browsers to your services will pretty much fast. However, they've also improved over time to have what we call the cloud front. So they have the cloud front in over 700 um, um, they have over 700 plus cloud front, which means in 13 regional edge caches. It's what this just means is, as you use, so if I visited a solution somewhere that is hosted in Canada Central from Africa, the cloud front are distributed cache that such that by the time I go to visit that same application, it would have created a replica of the application. It would have cached the application somewhere closer to me in what we call an edge location, such that it doesn't have to route down to Central Canada Central to deliver its content. This is just to help users have a very beautiful experience and have a very quick response to applications that are being deployed. So I will just go on here. I believe that gives you clarity to what a cloud front is and how AWS distributions work. Another very important thing with AWS are their instance types and the pricing model. It's very important to understand that AWS has various instance types, and they come with different prices depending on their workload and what you want to do and the cost preferences. So now we have instances that are general purpose, things around balanced compute, memory, and networking. They have compute optimized. These are high compute performance instances. So you see examples like T4G, T3, T3. If you don't understand, you don't worry. As we move on in the training, this will be put into proper perspective. But these are just naming conventions for the different types of servers. So a T4, the MCG, the M5. The M there actually means a medium type of server configuration, and what have you. So we have the RCG, we have the i4i, the i3, the d3. So these are memory optimized, storage optimized respectively, accelerated computing. So depending on what you want to achieve, what the major difference are in terms of how these instance types work are usually around their compute. So you have a 2 CP, 2 VP, 2 vCPUs, in 8 gig RAM. So your normal server configuration, depending on the sizes and the expected workload, is what will determine the one you'll be choosing. So they have different pricing model, which is very important. So usually what they are known for is their on-demand pay per second with no long-term commitment. It means that if I want to set up an instance, I don't need to pay now. I set up the instance based on the instance type that I've selected, will determine the cost implication, and if I don't need the instance, I can shut it down. So it means that the only cost I incurred are the costs between the period I started the instance and when I terminated this instance. These are pretty much used on the go. I want to quickly test the solution. I want to put my solution on a development environment and thereabout. So we have reserved instances. Reserved instances cost up to 75% discount from 1 to 3 years commitment. So what this means is, okay, if I'm very certain that I need to launch an instance that I'll be using for 2 years, 3 years, maybe for a solution that will be stable and running consistently, I don't need to use the on-demand approach. I can just purchase an instance, meaning that I'll make a commitment for 1 year, 2 years, and I get reasonable discount for that. So we also have the savings plan, so flexible pricing with up to 72% savings. You commit to consistent usage level for over 1 to 3 years. They also have the spot instances. They have the dedicated host. So now the dedicated host are physical servers dedicated to your use. We have dedicated instances. They're slightly different, but the dedicated instances run hardware dedicated to a single customer without the licensing benefit of a dedicated host. So now for a dedicated host, what this means is from your hardware to your the dedicated instance means that you have your own hardware in AWS environment. So you're not sharing racks with anybody. It means that the service that you are ordering is separate, and you can now get your licenses yourself. So they won't have to be the one maybe installing Microsoft SQL with its license for you. You have the right to install whatever services you want, whatever software you might be needing, and you can install your own licenses. So there are slight difference between the dedicated host and the dedicated instance, but the major thing is the dedicated instance runs your hardware for you. So a single customer to his own hardware in the AWS data center. So pretty much there are things we'll talk about as we move on, which are security groups and key pairs in AWS. Now, security groups are like firewalls for your instances. So this is where you set the security engagement between the private network and the external network. So what ports are you making available for people to access? You just give control over how your server will react to accessibility from the external servers or the general public. So this is where you set your inbound rules and the outbound rule, vice versa. So you can attach multiple security groups to an instance. So it means that you can have a security group that's being shared by different things. So now one of the things that AWS try to do is they make every component in isolation. So you want to access your server, you go create your key pair to access your server. You want to set up a security group, you create a security group, you attach it to your instance. You want to use 8 gig disk space, you go straight, get your disk space, attach it to your instance, and you can detach this disk space and add another storage to it. So depending on what you want to achieve, even when you set up your instance, you can scale it, meaning that, oh, I've gotten an 8 gig RAM, blah 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 blah, 4 CPUs, and whatever compute infrastructure that you might, sorry, not infrastructure, whatever hardware resources that you might need on your instance. And if you choose to scale up, all you just need to do is to change your instance type. It's pretty straightforward. You stop your instance, change your instance type. Just look at it like, okay, well, you want to increase the RAM on your system, you just turn it off, remove the 2 gig, turn it to 8 gig, and voila, you are moving. And all this happens with a click of your buttons. So there are different security groups. About security groups and keeper in AWS. So these are popular inbound rules that you'll be setting. If you don't understand it, don't worry. As we move on, you get to appreciate and understand how this works. So we have SSH, TCP, SSH inbound rule, which runs on the protocol TCP. Port range is 22. We have HTTP, you have HTTPS. So you have to enable this inbound rule for your instance to work with them. Now you can restrict SSH and RDP access to specific IP range. So it means that while you can make your settings to say, well, you want your solution to be accessible by the general public, you can as well just say within certain IPs are the ones that can access your service. While we're having a hands-on, you get to understand that better. Now for security, for key pairs are just secure authentication for your instances. So a key pair is used to securely connect to your EC2 instances via SSH or RDP for Windows. SSH for Linux, RDP for Windows. So how key pair works? Usually what happens is that once you create a key pair, a copy of the key downloads to your system, which you have to keep securely, because the other one will be automatically installed on your EC2 instance. So anytime you want to access this EC2 instances, you have to use the key pair. So an example of how you try to connect to a Linux server using your key pair and the SSH command. These are things that when we get to the hands-on session, we'll try. You have SSH, using the option I am referencing the key pair wherever it's saved on your system. So you have the username to your EC2 instance at the instance public IP address to connect to it. For those who are already familiar with connecting to servers using SSH, this would not be looking confusing to them. But if you are new to AWS, be rest assured these are piece of cake that you still devour. So we'll be seeing how to launch an EC2 instance. I'll stop here for now. You can join me in the next video to begin some little hands-on.